Hi there. This is a video about factoring, and what we're going to be doing in this video is talking about, well, what is the concept of factoring and the various methods on how to factor some polynomial. All right, so let's first talk about what the concept of factoring is. I like to think about factoring as rewrite as multiplication. Okay, and here's what I mean by that, is because if I take the number 6 and I want to factor the number 6, I simply rewrite that as the product of two numbers. And I can write that as 2 times 3. All right, and that's the idea. All right, the other thing that I think of when I think of factoring is it's the opposite of the distributive property. All right, and so let's take a look at an example of the opposite of the distributive property. All right, if I take like 3 times x plus 5, all right, and I want to distribute my 3 into this, I'm left with the expression 3x plus 15, all right? Now, what I want to think about is there can I go the opposite way? All right, is there something that I can factor out and rewrite as multiplication? So here, when you do this, all right, from this step to this step, you are distributing, okay? But to go from this step to this step, you are factoring, all right? And if you have a common factor, a common number that you can pull out that's divisible by 3 and by 15, which in that case is 3, you can factor out a 3 and you're left with x plus 5. All right, so it's going from one expression to the next and performing that, and thinking about the distributive property. Well, really, you're just multiplying. All right, and so that's the idea. All right, so sometimes let's take a look at another example here. Let's say that you had x squared plus 2x. And you want to factor this. That's what you're being asked to do. Well, you have a common number that you can pull out is your variable x, okay? And so what you can do, the technical way to kind of go about this is to say, well, this is really x times x and then plus 2 times x, all right? And you've got a common x value in each of your terms. If you have that common x value, you can factor that value out, and you're left with an x plus 2. And again, what you've done here is you've factored, all right? Going from one step to the next, you've factored. Now, to check to see if you're right, you can multiply that back out and see if you get the same thing, all right? So if you go back and you distribute that x, and you get x times x plus 2 times x times x is x squared plus 2x, and you land back at where you started, okay, then you've factored this correctly, all right, and this is your answer. So the next thing I want to talk about is factoring trinomials. Now, trinomials are polynomials with 3 terms. They're always of the form ax squared plus bx plus c, okay? And what I want to first talk about is when a is equal to 1, all right, when your leading coefficient is 1. And the first example that I have is the polynomial x squared plus 7x plus 12. Now, I'm going to factor this a number of ways, all right? When your leading coefficient is 1, all right, I usually just ask myself the question, what 2 numbers multiply to my last term, in this case 12, and then add to my middle term 7? All right, so I want 2 numbers that add to 12, that multiply to 12, and then add to 7, okay? That's typically how I initially go about this. And when we think of that, a lot of times what people will do is they'll list off the factors of 12. Well, the numbers that multiply to 12 are 1 and 12, 2 and 6, and then 3 and 4, okay? if I think of these pairs of numbers, all of these pairs of numbers are going to multiply to 12. But which ones of these pairs add to 7? And the answer to that question is 3 and 4. So if I can identify those two numbers, then I can rewrite x squared plus 7x plus 12 as the product of two binomials, and that's going to be x plus 3 times x plus 4. Okay? That's one way to do it. Now, to check your work, what you want to do is you want to multiply this out. Some use the FOIL method. That's where you multiply your first terms, which is x squared, your middle terms, which is 3, inside terms, which is 3 times x, your outside terms, which is 4x, and then your last terms, which is 3 times 4, which is going to give you 12. Combine your like terms, and you get x squared plus 7x plus 12. And so that's the idea. All right, that's how you can check. Now, the idea is that you're going from one step to the next, and all you're doing is rewriting this polynomial as the product of two binomials. All right, and this means that you have factored, okay? But then multiplying it out, all right, means you go the opposite way, and that means that you multiply, okay? And that's the idea. You want to be able to go from one to the next, okay? Now, the other way that we can do this is by using the box method, and I really, really like the box method. And I want to do x squared plus 7x plus 12 and demonstrate how we do this in the box method. Now, you can always, this is kind of my new like fail-safe way on how to factor things. But what I do is I take my first term, which is x squared, and I put it in this box here, x squared. I take my last term, which is 12, and I put a 12 down here. And then I begin to ask myself questions. And I say, okay, what two things are going to multiply to give me x squared? And that's going to be x times x. So those numbers are going to go up here, x and x. And then I ask myself the question, well, what two numbers are going to multiply together to give me 12? And you got a lot of options, but we also want these two boxes here to add to 7. And let me show you what I mean. So if I say that we can do 3x, just 3 and 4. Those two numbers are going to multiply to 12. So 3 times 4 gives you 12. And then we can fill in these other two boxes. And if I take 4 and multiply it by x, I'm going to get 4x in this box. And if I multiply 3 by x, I'm going to get a 3x in this box. And if I add these two terms together, we get 7x, which is our middle term, and that's what we're looking for. So then my final answer is going to be x plus 3 times x plus 4. And you can verify that this works by using the box method. And again, going from one step to the next, you're going from here to here. This is the concept of factoring. That's our goal, is to write a polynomial as its binomial factors, okay? And that's the idea. All right, the next example that I want to do is factor this polynomial here, this trinomial, a squared minus 3a minus 40, okay? And what we want to do is try to answer the question, two numbers that multiply to negative 40, but then add to negative 3. And this is a tough question to answer, okay? You know, if you write out the factors of 40, all right, you've got 1, 2, 4, 5, 8, 10, 20, and 40. What combination, because one of these numbers needs to be positive and one of them needs to be negative. If they need to add to negative 3, what are we going to do? If you look at 4 and 10, you know, your options are, you have to kind of look at it as you're going to add them together or you're going to subtract. All right, and so you'd have like 14 or 6 or negative 6 and negative 14, that kind of thing. And so when I look at this, I know the answer is 5 and 8, okay? But here's what I've got. I've got to say that this is negative 8 and positive 5. Because then I can factor this out and say a minus 8 times a minus 5. And if I a plus 5. All right, if I multiply these out, all right, negative 8 times 5 gives me negative 40. Then if I add these two numbers together, I get negative 3. All right, and I want to show you doing this using the box method. All right, and one of the things I like about the box method is that it's kind of a trial and error concept. All right. And so from here, if I draw a box, and I'm going to do this a couple times. All right, I'm going to kind of make some mistakes and show you where you can do this. All right. So if I ask myself the question, I put my first term here and my last term here. I ask myself the question, what two things multiply to a squared? Well, that's a and a. Okay, that works. All right, that's fine. But now two numbers that multiply to negative 40. Well, what you can do is just try some numbers out, and you can say, well, let's try, negative 10 and positive 4. All right. Now let's fill in these boxes here, because when I add these two boxes together, I want to get negative 3a as a result. So if I do 4a, 4 times a is 4a, negative 10 times a is negative 10a, and I add these together, we're going to get negative 6a out of that. All right, and that's not right. So that's not the same. So no, that's not going to work. Let's try something else. And then you may think about it and you're like, let's try 8 and 5 because I know that that's going to add to 3. All right, so I put a squared here, negative 40 here. Let's just try it again. And so then you've got a times a, and then you go, all right, well, let's try negative 5 and positive 8. Because these two numbers are going to multiply to negative 40. That's the goal. They got to multiply to this, but then add to that middle term. So from here, then you've got 8a, and then you've got negative 5a. Well, when you add those together, you get positive 3a, and that's not the same, so no. But then you're like, oh, in order for me to get negative 3 out of that, I got to make the 8 negative, and I got to make the 5 positive. So let's try that. 8a plus 5, a minus 8. We get a squared here. You get negative 40 down here. This is negative 8a. This is positive 5a. And you add those together, you get negative 3a. That works. So in order to factor this, you get a plus 5 times a minus 8. All right. And the goal is to go from here to here. All right. If you got to use the box method, I think that this is good because it's a visual way. It's a way for you to check what you're doing. And most importantly, it helps when your leading value out here is not 1. Your leading coefficient is not 1. So let's take a look at that. All right, so on this next example, this is when your leading coefficient is not 1. For this, you cannot ask yourself the question, what two numbers multiply to 42 and add to 55? It just doesn't work, okay? So in this example, you can do this a couple different ways, but I like to use the box method because the box method to me is a fail-safe way to do this. You can keep trying different combinations and it will work, all right? So first things first, let's put 7x squared in this box here, and let's put positive 42 in this box down here. And when we add these two boxes here in here, they need to add to our middle term 55x. So from here, we ask ourselves the same question. We say, what two numbers are going to multiply together to give us 7x squared? And that's going to be 7x and x, okay? Now, the next thing I want to do is then say, what two numbers are going to multiply to 42? Now, let's try this. Let's try just the numbers 6 and 7, okay? These two numbers multiply to 42, all right? And so then you would say, let's fill in these boxes. Well, 7 times 7x is going to give us 49x. And 6 times x is going to give us 6x. Now, when we add these two things together, we get 55x, which is what we're looking for. All right, that's the goal. And so when we do this, this is going to factor then to x plus 7 times 7x plus 6. And you're probably wondering, well, how did you do that? How did you know the 6 goes there and the 7 goes there? Couldn't, if you flip them around, what's going to happen? Well, let's try that. If I do this and I put 7x squared here and 42 here, if I put a 7x here and an x here, look what I've got. If I put a 7 here and a 6 here, all of a sudden I'm doing 6 times 7, which gives us 42x. If I do 7 times x, I'm going to get 7x here. And when we add these together, that's going to give us 49x. And I know that that's wrong. One of the things you got to also think about is that if there's no common number that I can factor out, okay, of this trinomial. Given 7x plus 7, if that's one of my factors, let's just hypothetically say that it is 7x plus 7 times x plus 6, all right? That means that I could factor a 7 out of my first term here, which gives us x plus 1 and then x plus 6. And the question is can you factor a 7 out of your original equation? And the answer to that question is no, you can't. So if you always want to look to see if you can factor out the greatest common factor, and if I can't factor out a 7, that's not going to work, okay? The box method already kind of tells me that's not going to work, but that kind of helps me, that allows me to then say, all right, I know I can't put a 7 here, I got to put the 7 down here. When we're doing the box method. Okay, so the box method, just keep trying different things. If you try this first and they're like, oh, well, that didn't work. Well, let's try switching these and to see if we get the right answer. All right, and that's the idea. So the last one I want to do is another one where, we have a leading coefficient that isn't 1. All right, so I would, want to use the box method on this. One of the things that I want to look at is, and we're going to do this a couple different ways. I'm going to put 9x squared in my first box, 12 in our second box, all right? And so if I'm asking myself this question, what two things multiply together to give me 9x squared? Well, let's try 3x and 3x. Okay, that's going to multiply together to give me 9x squared. All right, now let's try the 12, okay? And so on this, again, I can't, number one, I can't factor anything out of here, all right? 31's a prime number. I could factor a 3 out of the 9 and 12, but it's got to be able to do it with all 3. So let's just try, 3 and 4. All right, so plus 4, plus 3. And so, 3 times 3x gives us 9x, and then 4 times 3x is 12x. So if we combine those, that's going to give me 21x. All right, and that's not the same as 31x, so no. So let's try something else. All right, let's again come in here. Let's do 9x squared. Let's do 12. So let's try 3x again and 3x, and let's try 2 and 6. Okay, so 2 times 3x is 6x. 6 times 3x is 18x. If I add these two things together down here, that's going to give us 24x. Again, that doesn't match what we have here. Well, let's try 1 and 12. All right, so if I do this, if I got 9x squared and positive 12 here, let's try 3x and x. Let's try 12 and 1. So 1 times 3x is 3x. Let's try, or that's a 3x. 12 times 3x is 36. So 3x plus 36 is 39x, and that's, again, no. All right. So when that doesn't work, all right, 3x and 3x, all right, we've tried all of our combinations. We've tried 1 and 12, 2 and 6, 3 and 4. All right, let's try something else. All right, let's try using, 9x squared goes here, 12 goes here. Let's try 9x, and let's try x. So let's do this. Let's do 3 down here, and let's do 4. And sometimes you can kind of, do the math in your head before you actually get there. But this is going to work. So we've got 4x, and then we've got 27x. And when I add these together, that does give us 31x. That means that this works. So we can factor this to 9x plus 4, and then x plus 3. And that's the idea, okay? And that's what we want to look at. So sometimes it is a bit of guess and check. But, if you keep trying things and it doesn't work, that's okay. All right, let's try this. Let's try x squared plus 5x plus 3. All right, and I want to factor this and see what we get. And so x squared goes here, 3 goes down here. X and x has to multiply to x squared. And then the problem is that 3, because that's a prime number, we only have one option. We have to do 1 and 3. And so with that, 1 times 1 gives us 3. Well, let's see what we get here. 3 times x gives us 3x, and 1 times x gives us x, and that gives us 4x. And that's no, that doesn't work. There are no other combinations. Okay? And so because there are no other combinations, then what happens is that this is what we call a prime polynomial, means that it can't be factored. All right? And that's okay. Not every polynomial can be factored. So once you've expended, and I use these numbers because they're pretty simple and easy because I only have one option for 2 numbers that multiply to 3, is because if I have no other combinations, you got to try every other combination. And so that's where that one before, on this, like because 9 is not a prime number, nor is 12, and I've got some options, you will encounter problems that you may have to do it like 3 or 4 times before you do actually find that combination. All right, and that's okay. So but that's the idea. The more and more you practice this, the better you get. This is such a huge concept throughout the rest of your math career that it's really important that you know how to do this. And so the box method is the way to go on this. All right. I'll make another video on how to use something that we call the X method or the AC method later. Thanks. All right, see you in a bit. Bye.